In this video, we're going to start the KutaSoftware Infinite Geometry free worksheet, Secant Angles. So quickly, let's go over what a secant is. We already know what a chord is. A chord is a line segment drawn from one point on the circle to another point on the circle. A secant essentially extends out past that chord. So a secant is the line. So a chord is technically part of a secant. Now for numbers 1 through 8, it's asking us to find the measure of the arc or angle indicated. And we're to assume that the lines which appear to be tangent are tangent. So we're going to be using two different formulas. The first formula is for angles formed by intersecting chords. So that's where the intersection appears inside of the circle. The second formula will be angles formed by intersecting secants. So angles that are formed outside of the circle. Now, the formula that we're going to be using will help us find one angle. So the angle measure that's formed by intersecting chords, so one singular angle formed by those intersecting chords, will be equal to half the sum of the intercepted arcs. So looking at number 1, we can see that we have chord QS and we have chord RA. The angle we're looking for is angle QPR. So angle QPR is formed by those two intersecting chords. So angle QPR is going to equal half of the sum of the intercepted arcs. So RQ is one of those intercepted arcs, and SA is one of those intercepted arcs. Now note, if we were looking for angle QPA, then the intercepted arcs we would use would be QA and RS. So angle QPR is equal to half of arc RQ, which is 175 degrees, plus SA, arc SA, which measures to be 55 degrees. So angle QPR equals 1/2 of 175 plus 55. 175 plus 55 is 230, and when we take half of 230 degrees, we get 115 degrees. So 115 degrees is the indicated angle in number 1. Now when dealing with angles formed by intersecting secants, we're looking at a single angle, so that formula will be 1/2 the difference of intercepted arcs. So when the intersection occurs inside the circle, we're going to take the sum of the intersected arcs. When it occurs outside the circle, we're taking the difference of the intercepted arcs. So in number 2, we can see that RT is a secant and RF is a secant, where QF is a chord and S to T is a chord. Because those secants intersect, we can use our formula to solve for the indicated angle. So angle SRQ, that angle is going to be equal to half the difference of the intercepted arcs. And that's going to be the larger arc minus the smaller arc, because we don't want a negative number if we're dealing with the measure of an angle. So the larger arc, FT, minus the smaller arc, SQ. So angle SRQ is going to equal half of 140 minus 50 degrees. So 1/2 of 140 minus 50 is 1/2 of 90 degrees. And half of 90 degrees is 45 degrees. So in number 2, our indicated angle has a measure of 45 degrees. Let's continue on to number 3. In number 3, we have an intersection that occurs outside the circle, and it's an intersection of secants, so we can indeed use our formula. So that angle, HGF or TGE, is going to equal half of one intercepted arc, the larger arc, minus the smaller arc. So that's arc TE minus arc HF. So that's going to equal 1/2 of TE, which is 175 degrees, minus 57 degrees. 175 minus 57 equals 118. So now we just have to multiply 1/2 by 118 degrees, or divide 118 degrees by 2. And when we do that, we'll get 59 degrees. So our indicated angle is 59 degrees in number 3. In number 4, the intersection occurs within the circle. So this angle UVT is equal to half the sum of the intercepted arcs, which is arc UT plus arc SF. So angle UVT equals 1/2 of UT, which is 175 degrees, plus SF of 53 degrees. So that's 1/2 of 228 degrees. And 228 degrees times 1/2 equals 114 degrees. So 114 degrees is our solution in number 4. And number 5, notice that the intersection of the chords occurs on the edge of the circle. So those chords share a common endpoint. So now we can use the formula where the inscribed angle equals half of the arc. So the inscribed angle, angle RQP, is going to be equal to half the measurement of that one intercepted arc of 194 degrees. So 1/2 of 194 is equal to 97 degrees. And number 6, again, you can see that our intersection of chords occurs on the edge of the circle. So the common endpoint that the chords share, that vertex, lies on the edge. Therefore, this is an inscribed angle. And we know that the inscribed angle is half the measurement of that intercepted arc. So angle DCB will equal 1/2 of 144 degrees. And 1/2 of 144 degrees is 72 degrees. So 72 degrees is our solution in number 6. In number 7, our chords intersect inside the circle. However, remember the formula. It's the fact that an angle formed by those intersecting chords will equal half the sum of the intersected arcs, where one of the arcs is our unknown. That's arc BC. So angle BDC will equal half the sum of arc AE plus arc BC. Now, we know that angle BDC is 85 degrees, and we know that arc AE is 70 degrees, but BC is our unknown, which is what we're solving for. So I can either start by distributing that 1/2, or I can just simply multiply by 2 at the start. When I multiply by 2, my 2 and 1/2 will cancel out, so 2 times 85 degrees is equal to 170 degrees, and that's equal to 70 degrees plus arc BC, the measure of that arc. So when I subtract 70 degrees from both sides, I'll have the 100 degrees equals the measure of arc BC, our indicated arc in number 7. And lastly, for this set of directions, number 8. Again, the intersection occurs within our circle. We're given that one of the angle measures is 120 degrees. So 120 degrees is going to be equal to half the sum of the intercepted arcs. So that's going to be 60 degrees, so 1/2 of 60 degrees, plus our unknown, the measure of arc UT. This time I'll distribute the 1/2, just to show you that there's more than one way to solve for an equation. So we'll have 120 degrees equal to 30 degrees plus half of arc UT. I'll subtract 30 degrees from both sides to get that 90 degrees is equal to half of arc UT. My last step is to multiply both sides by 2. 1/2 times 2 is 1, so we'll be left with the measure of arc UT equal to 2 times 90, which is 180 degrees. Now in the rest of this video, I'm going to finish out the first page. Our directions for this next section are to solve for x and assume that the lines which appear to be tangent are tangent. And number 9, since the chords intersect on the edge of the circle, they form an inscribed angle. So 70 degrees is going to equal, that inscribed angle will equal half the measurement of the intercepted arc of 141x minus 1. I'll start by multiplying both sides by 2 to get that 140 is equal to 141x minus 1. Then I'll add 1 to both sides. 141 equals 141x. And when I divide by 141, any number divided by itself is 1. So 141 divided by 141 is 1, and that's equal to 1 times x, which is x. So 1 is x in number 9. Moving on to number 10, you can see that our intersection of secants occurs outside of the circle. Therefore, that measurement of 50 degrees is going to equal half of the difference of the arcs. So that's the larger arc PD of 12x plus 8 minus the smaller arc QS of 4x plus 4. I'll start by multiplying both sides by 2 to get 100 degrees on my left hand side so that my 1/2 and 2 will cancel out, and then I'm going to distribute this negative, essentially distributing -1. So it'll be 12x plus 8 minus 4x minus 4. And I had to distribute that because since this entire arc is subtracted, this 4 will also be subtracted, not just the 4x. So I'll combine 12x and -4x or minus 4x, and then I'll combine 8 and plus -4 or minus 4. So 100 degrees will equal 12x minus 4x, which is 8x, plus 8 minus 4, which is 4. I'll subtract 4 from both sides to get that 96 is equal to 8x. And when I divide by 8, I'll get that 12 is equal to x. So 12 is my final solution in this video. Join me in the next video where I'll continue on with numbers 11 through 18, finishing this worksheet. If you have any questions, leave them in the comments below. And as always, like, subscribe, and share.